All right, I'm waiting for it. I'm waiting for it. I'm looking at the clock. I'm looking at the clock. It's a long half minute. Waiting for it. Ah, there we go. Yay. It is 2 hours UTC. Long half minute. And I forgot to turn this off again. Ah, there we go. Yay. It is 2 hours UTC. Okay. Well, hey, everybody. It is 2 hours UTC, and it's time again for Astronomy Daily Live. So welcome, friends. Come on in. Come on in. Hope everybody's doing well. These live streams that I don't do. It feels like a really long time since the last one. It's like, man, how long has it been? And it hasn't been very long at all. So a couple days, but yeah, in when I guess when this is done sort of daily, right? This kind of a frequency, then a missed day really seems a lot longer than what it actually is. So yeah, good to be here. Good to be here. Come on in, friends. I see Atta is in the chat. Let's see who else. Does anybody else get over there? Uncle Bill and Tom. Hey, nice to see you again in the chat. And on the panel is Bobby. Hey, what's going on?
Hey. And you're right. It's been 2 spins. So what did you do yesterday?
Oh, I just had some things to run around. I had to go get some stuff, and I wasn't quite sure if I was going to be able to get back in time. And so, that's the kind of thing, like I've said many times, and I'll say it many more times, and that is there are very few things that I hate and sort of, try in earnest to change or just not have to do that. But there is one thing, and that is hurrying. I hate to hurry above all more than anything else, right? I mean, there's a lot of things to potentially hate, and I really don't, but I hate having to hurry and having to rush. So, this kind of a live stream, because it is daily, because it's really casual and friendly, right? That's what part of being a friend is forgiving, and it's like, forget about it, So that's what I hope that you all do when I'm not able to do this every single day. So because I think we're good friends here, and we're also not little kids, so we can understand when things come up and not exactly expected, and it's like, whatever, right? I mean, you can't always do that, right? I mean, if this live stream was like a class, right? It's a class that had a schedule. It's like, well, I've got to do that. But I mean, really, this live stream has absolutely no schedule at all. I mean, every single day, I'm sort of doing the Buddhist thing here, right? It's like, am I going to do the live stream today, right? And that's all I think about. I don't worry about tomorrow's one or next week's or next month's, because that's not what this is all about. This is about having fun, sharing a passion, and just having a good time, enjoying where we find ourselves, which I sort of consider to be in a kind of a very unusual and strange position, right? Not quite sure, right? Uh, but whatever it is, it seems pretty interesting, and I like it so far. So yeah, so
You don't belong to any shortwave groups, huh? On
I
Facebook.
I I belong to one radio group on Facebook. It's
Yeah,
called,
what's that called?
well, I'm trying to remember. I think it's called Cats and Radios. Either Cats and Radios or Radios and Cats.
Okay, because there's a shortwave radio group that you should definitely try to avoid. Its administrative panel is very, very nasty out there.
Oh, okay. What's it called?
Shortwave radio listening group.
Okay. Well, if those kinds of things must be avoided, then I encourage you to do so. Yeah. There is no reason. I mean,
And I'm not sure you know Jordan Haber, but he's the one that gave us the warning.
okay. Well, that is greatly appreciated. Greatly appreciated. If we knew what abundance we actually live in, I think a lot of our fighting would go away, right? And I mean, I've talked about this a few times. This idea of a post-scarcity society, and what does life look like when anything you need or want you can have? I mean, literally, right? So, eat as much as you want, drink as much as you want, have as many cars as you want. It just doesn't matter because the resources are there to make that possible, right? And I mean, it's all free too, right? I mean, you don't have to. The only thing that you are required to do is in some way express your need or your want, right? Well, it's like, well, what does society look like in that kind of a scenario, right? I
I'd like to
mean,
welcome Crystal Gems and Ray L, who has a
oh,
nice advice about that group.
oh yeah, let me see. I'm gonna pull up my chat. So Crystal, nice to see you again in the chat. Rael, glad you could come back. Um, Interesting. Yeah. Well, as I was saying, I understand that we're still under the delusion that there isn't enough to go around. That there are limited resources. Um, that I've got to get mine. So that means I've got to take yours. Well, so be it. All of that. Well, I mean, we're getting closer and closer to a point where that kind of a situation is just going to go away, right? Because I mean, the universe is a big place, and even in our very, 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 very local area, right? There's a lot of stuff. There's a lot of stuff. There's not only a lot of stuff, but there's a lot of energy, right? There's a lot and different kinds of energy, right? So we've got more energy than what we could possibly use, probably, and we have more stuff than we could possibly need to make anything that we want, right? So, I mean, that's a fact. That's an absolute fact. I mean, they have found, right? asteroids that are, you know, more or less pure iron, right? Pure iron, a little bit of rock, you know, but big, you know, multi-kilometer uh, wide asteroids that are pure iron, right? I mean,
And
it's
before
like,
you continue, Altawa says she lived in South Africa for 6 years and saw people die every day for lack of resources. The
yeah,
problem is equitable distribution.
yeah, you know, Atta, I'm going to go off on a little tangent here. Back in the early 90s, I got involved with hunger, right? You know, this the problem of hunger, and I was involved with that for many years. I volunteered at the food bank, and I worked with this one organization. It was called Results, and I think that might have stood for something. I'm not exactly sure, but you know, I mean, it was just a um, NGO that wasn't an NGO. No, it wasn't an NGO. I forget exactly. Anyway, you know, we wrote letters and postcards and did, you know, phone bank things and all of that. And it was a really interesting experience. What made me stop um, was when I realized that 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 the hunger problem isn't for lack of resources. There is more food being produced right now that could fill everyone, right? At at least at least by a factor of two, right? At least, right? Um, so it's not that we don't have enough. It it is absolutely, positively, totally, 100% a political thing. It's a way to control,
And
and it's very,
best to have access to share it with those who live and want. Good luck with that.
yeah, yeah. Um, but it's a political thing, and I mean, I was working really closely with this group that wanted to, and I think this was maybe 1990. Oh, I don't know, 1990, 91. I forget exactly when Somalia was in the news. They were having the famine there. They were having the civil war. Um, it was just a nasty situation. Well, we got a hold of ourselves a barge full of rice, right, from Louisiana, in fact, or at least coming out of Louisiana. We had, you know, I don't know how many tons, right? Tons and tons and tons and tons and tons and tons and tons. And it's like we are, I mean, we, uh, through donations and grants and all of this, um, uh, we bought the barge, right? We bought everything on there, and you know, got a crew to, you know, sail it over there, and you know, the whole thing. We had it all worked out, and it never left port because somebody somewhere said no, no, we're not going to do it. Forget it, and that's it.
I think
That's
when
it.
Kristen Jansen on law has a great conversation if you check the chat.
Yeah, I'm seeing it. I'm seeing it. So yeah, I mean, we 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 have we have lived under under this scarcity society, and we do to this day, right? But a lot of the current scarcity is being caused by others, right? It's not that there actually is scarcity, but but that scarcity can be created because, see, with scarcity, right? It's basic economics. When when there's a little bit of something that people really, really want, then it's gonna cost a lot, right?
Now,
Supply
are we
and
still
demand.
in corruption ever since, or what?
I think that humans are going to be humans, and there are always going to be creeps. But I'm hoping that once we sort of move into this non-scarcity society, a lot of people are just going to sort of relax and yeah, not be like we are now, right? I think that we're
Like
always
this
going.
psycho is where there's corruption, there's fixation, corruption, fixation, and all that.
Yeah, yeah. It's just it's all based on scarcity and being an astronomer, right? I mean, it's really interesting, right? That I mean, astronomers of all people, right, have this perspective on the universe where I mean we can, I mean when we look at a spectrum, right? Not only are we identifying atoms and molecules, excuse me, but we can actually measure how much of that. And when we go out and look at things, right? We can look at asteroids, we can look at stars, we can look at galaxies, whatever, right? We are seeing a lot of stuff. There's a lot of stuff. There is more stuff um, than we could possibly know what to do with, right? So,
And lots of good points if you check the chat.
okay, then Boston space, yes, just on a
Check the
spaceship
one from L, the latest.
ourselves. Um, yeah, yeah, and if they're hungry, I mean, I've never really been what I would consider hungry, right? I mean, I used to fast, for a couple days each each month, right? Um, I don't consider that feeling hungry. Not not in the ways that that some people on this planet are dealing with right now, right? What I'm saying is right now that is completely unnecessary. Totally, totally. Um, it's just a control thing. And yeah, if you're hungry and in fear, uh, you are completely controllable. Completely. I mean, anybody would be. It's not as if it's sort of them that are. Okay, anybody, you, me, whatever. If you're extremely hungry and extremely afraid, you're pretty much going to do anything you're told. Yep.
Yeah.
Yep, absolutely. So, but that's the cool thing about being an astronomer, right? Is that we have this perspective. We know, right, that there's a lot of stuff out there and it's nearby, right? I mean, it's not as if we have to go very far, right? I mean, with the kind of technology that we are working on now, um, and sort of the new stuff too, right? Really don't know uh, what is possible. We really, really, really don't know. But what we do
And
know is that there is a lot of stuff out there. Go ahead, Bobby.
and also Laura actually said astronomy has an almost spiritual effect. And like and Crystal Gems agreeing with Ray L. True, and they use it.
Yeah, absolutely, absolutely. So yeah, being an astronomer, having an astronomical perspective, um, you know, um, forces us into the realization that there is a lot of stuff, and there is more than enough to go around, right?
I guess what Crystal Gem says is true. The galaxy is too beautiful to waste judgment on her or anyone.
Yeah, yeah, I totally agree. Totally agree. So yeah, it's just there. It's too big. There's too much stuff, and to think for 1 second that we don't have enough, that's becoming a ridiculous thought. Just an absolutely ridiculous thought. Now, I don't think that we're quite there yet. I think we're still sort of living in this scarcity thing, right? Because I mean, there are, you know, still a lot of things, right, that more or less control us, right?
I
Money.
had my church's hymn book. I think one of the lyrics it says, "Who am I to judge another?" I want to know what that number is and stuff. But I don't have the handbook with me.
Huh. Yeah, well, that's an old thought, an old wise thought, for sure, for sure. I I think that this universe is just way too much fun. I Yeah, it's just way too much fun to be hanging around and seeing what can be seen and experienced and all of that. It's great. Yeah, and I'm glad that I've got the astronomical perspective, because I think that really, I mean, for me that greatly sort of enhances the whole experience, to have a little bit of that kind of depth, right? There's all kinds of different variations on depth, but having a pretty good understanding, uh, at least of what we think all this is, yeah, makes it nice. Yeah, well, yeah, and Atta, you're right. Yeah, you're right. You're right. I don't know if the tables were turned, if the situation would be much different. I don't know. Don't know. Cheers! I've got the full mug here. The full mug of HOH. Cheers.
Okay. It's actually in the LDS hymn book number 220. The song of the hymn is called "Water Without Thee." If you look at the second verse, it will say, "Who am I to judge another when I work imperfectly? In the quiet heart is heat and sorrow the eye can't see. Who am I to judge another? Water without thee."
Very cool. Yep. Yep. I think judgment takes a lot of energy, because you have to create the judgment, and then you have to hold on to it. You have to remember it, and yeah, that just takes a little bit more energy than what I want to expend. I want to expend energy on doing things that I enjoy, right? So, WATER. Yes.
And thank you, Auto for that compliment.
Well, speaking of WATER, I came across an interesting paper on today's archive.org list, and it stopped me in my tracks. I didn't go any further because I wanted to see what this was all about. Because yeah, it's well, it's not I don't think that it's anything that I would necessarily be interested in studying, but I I do think it's pretty neat, and at at least according to the paper, there's some interesting things going to be happening in the future with this. So I'm not going to waste any more time here. I'm going to share my screen and go over to this paper.
The pepper.
So this is the, I'll zoom in here a little bit. So this is the 2018 census of interstellar, circumstellar, extragalactic, protoplanetary disk, and exoplanetary molecules. So, yeah, so here it is in the abstract. They've identified, or we, as a species, I guess you can say, we have identified 204 molecules in space so far. 204. That's pretty good, right? And quite a complex combination, right? Yeah. So they found, the simplest molecules, two atoms, up to the buckyballs, C60 and C70.
Yeah,
So
I want to stop right there because Ray L has something about WWB time service to sync the clocks. They're saying that the Congress wants to shut it down next year. And so he's urging everybody to write to Congress or sign those petitions. I'm not sure if those petitions got a response to them and stuff. But it would also be better if you did write to Congress about it.
Yeah, Ray, I definitely think that you should definitely do what you think that you need to do, but I'm having my extreme doubts that WWV is going to be shut down. I think that to me, yeah, I guess, well, okay. Now, I have not investigated this, right? So I'm not exactly sure what the status of things are. But
and you use WWV for your applications, right?
Well, WWV is used by a lot of different kinds of things. I mean, the astronomical world, at least, in the United States, right? All the telescopes are synchronized to WWV. So all of them are. I mean, maybe they're also doing, like GPS or something. Not exactly sure, but I mean, WWV is the standard, right? It's like the thing, at least over here. So, but yeah, so as I said, I haven't investigated this, but I'm thinking that that every budget cycle, everything is up for examination. That's how it should be, right? I mean, you should look at these things, each item that you're paying for, and see if you still need it or not. So, the media has a hard time reporting anything very accurately, right? And I say that based on what I observe in terms of the media reporting on astronomical things. Many times, what they say isn't exactly wrong, but it is definitely not correct because something has been misinterpreted, right? Not understood because you're not an astronomer, right? I mean, you're not thinking like this. You're just trying to report, some news items. So, yeah, I'm not exactly sure, not knowing what the status of things are. I'm just not exactly sure if the concern about WWV going away is a real one, or if it's some kind of a media report that's being misinterpreted. Not exactly sure because, yeah, I think WWV is pretty widespread used. And Uncle Bill, if I'm understanding you correct, I think you and I agree. Yeah. Okay. Yeah. So, that's just my thoughts on that. Let's get back to molecules in the universe. All right. So far, we've identified 204 different molecules. Now, this is a huge paper, right? This I don't even know if I would necessarily call this a paper. This is more, like I'm not exactly sure. Maybe a chapter out of a book. Hard to tell exactly. 68 pages long, and I'll show you why. So yeah, I always like these introductions because they oftentimes give sort of a history and, sort of a lead in to the work that's going to be presented, right? And so, yeah, again, if you like, to get into the history of astronomy, any introduction to any paper is going to set you on a path. And then just follow the references back, right? So, yeah, let's see. So the first molecule ever identified was CH. Very cool. And it was identified in 1937. Beginning in the early 60s, the advent of radio astronomy really exploded that discovery rate. So let's see. The one thing that I didn't know, and I'm trying to see where I saw that now. So these molecules are emitting light at radio wavelengths, right? So pretty long wavelength, at least relative, to visible wavelength. In the megahertz or gigahertz range. So, but they emit these radio waves by vibrating, right? So it's not like the regular sort of atomic way of doing things where you have the electrons jumping in between states of energy and either emitting or absorbing light. What's happening in this case is you have a molecule that is vibrating in some way, and these molecules can vibrate in many different ways, right? Different modes. different resonances. It's, I mean, it gets complicated really, really, really fast.
Yeah. Okay, so Ray L wrote to NIST. They told me the way it stands right now, it will go in 2019. But I have a hard time thinking it will. It was on the cut board last year as well. And it has been raining in southern Illinois the last 2 days. He can't even get his telescope out.
Ah, bummer. Yeah, it's the.
Thanks for blowing me down because what happened, my computer crashed.
Oh, okay, all right. Yeah, I was wondering about that. So, it will go away in 2019. Yeah, I don't know. I've got a hard time with that. Yeah, they're going to have to come up with some kind of alternative if that goes away, and you know.
I can't even put my telescopic whip out so I can do my BHF UHF listening.
Yeah. So
it's been raining randomly here in Louisiana.
Yeah. Well, it's good to see you too, Crystal, in the chat there. Nice to see you. All right, let's keep going here. Let's see. Yep, we're going to do this one. So here's their list of molecules that have between 2 atoms and 7 atoms each. And then, yeah, they're saying here also vertically ordered by detection year. So I guess, I don't know if it goes this way or if it goes this way. Not sure. But pretty good, right? Let's see, I'm seeing carbon, hydrogen, nitrogen, oxygen, silicon, sulfur, chlorine, sodium, aluminum. That's potassium, right? Yeah, potassium. Phosphorus is P? I think so. So then you've got
you just can't win with Mother Nature today.
Well, I think it's just, I mean, it's absolutely fabulous that we're finding all of these things, out in space. Oh, okay. Yeah, let me I'm going to keep track of the chat here too. Cool. Yeah, I went to a conference at I think it's University of Illinois, Champaign-Urbana, where the big supercomputer center is there. Yeah, that was pretty interesting. Yeah, it's the astronomers' biggest problem is the clouds and no cloud filter. You've got to get into radio astronomy. See, with radio astronomy, there is no atmosphere. So let's see.
How goes an SDR goes to radio astronomy?
What's that?
I wonder what an SDR goes through radio astronomy.
I don't know. You'd have to try it out. Okay, let's see. Titanium, argon. Wow. Argon. They have detected argon. Interesting.
Yeah, welcome, Remar, clouds and light pollution.
What's that? Hey there, Remar. Nice to see you in the chat. Welcome, welcome. We're just looking at some at the list of molecules that have been detected in space, and so they've organized them according to the number of atoms in the molecules. And I'm just sort of identifying atoms, right? So silicon, carbon, magnesium, cool. Aluminum again, titanium again, iron, nice. So you see, I mean, we've only identified 204 molecules. I mean, there are billions of molecules, right? Of different molecules. So yeah, we've just started. We've just started, and look at how much stuff there is, right? I was talking about stuff, right? This is a lot of stuff. I mean, in order to see these things, right, there has to be enough of it to emit, you know, bright enough in the radio for our radio telescopes and detectors to see it, right? So there already has to be a whole bunch, right? It's not as if, you know, there's a molecule here and a molecule there. It's like it's everywhere. So yeah, it's extremely cool to see both, you know, the atomic species here, like magnesium and aluminum and silicon and iron. That's very, very cool. But it's also very, very cool, right, to see these stable molecules that are just vibrating like they normally would, and sending us some radio signals. So very cool. And these, you know, these are getting really complicated. So there's 7 atoms. Here's 8. Here's 9. Here's 10. 11, 12, 13. So they found a molecule with 13 atoms in it out in space. I'm not sure what this C is at the beginning there. I'm not quite sure what that is. And of course they found, you know, the fullerenes too. At least a couple of them. So pretty awesome that all of this stuff is out there. I mean, the basic, you know, building blocks of life plus a few other trace things. I mean, it's all here. You've got your water, right? You've got your carbon. You've got carbon everywhere. You've got your hydrogen, your nitrogen, your oxygen. You're set. Tons of it. More than what we could possibly ever need. Now, this is a little bit out of reach, right? This stuff is probably a little bit, you know, out of reach. But the idea here is that this stuff is probably everywhere, right? I mean, it's probably concentrated in certain areas, but it's probably everywhere. Probably. Let's see. So radio astronomy, that's of course how they're doing this. But yeah, these radio waves, as I said, are coming from either the rotational motion of the molecules or their vibrations, right? So it's just molecules rotating and vibrating. And they emit energy that we can see. It's amazing. Let's see. Yeah, so the infrared is more of the vibrational, I guess. Okay, so radio is more of rotation, and infrared, which is obviously shorter wavelengths, is more vibrational. That makes sense. So then what they do in section 3 here is they go through each and every molecule. Every single one gets a paragraph, right? Which I think is absolutely fabulous because you can, you know, you know, this is just a detailed summary of what is known about each of these molecules. I thought it was interesting that, you know, this particular molecule was sort of, you know, identified in 1937, but not radio identified until 1973. So yeah, these guys go through every single molecule and give it a paragraph. So I thought that was pretty amazing, right? I mean, if you want to know a little bit more about any of these, right? This is what it's all about, right? So silicon monosulfide, first detected in 1975. If you want to look at the paper, there it is. So this is some kind of rotational transition, I guess, at like 108 gigahertz and 90 gigahertz. So of course, you know, with being able to identify spectral features, we have to have laboratories that are, you know, making the measurements. So we have, you know, something to compare it to, right? It's like a standard. And so, you know, we can take a radio spectrum of, in this case, right, silicon monosulfide, and this person back in 1965 did that and found that it emitted at these frequencies. And so when you go and look into space and you see emissions, you know, strong emissions at those two frequencies, it's like, well, it matches the laboratory measurement, so we're pretty confident that that is what it is. So that's pretty cool. 1975. C2, nitric oxide, hydrogen chloride, right? Hydrogen chloride, isn't that, that's hydrochloric acid, right? 1985 in the Kuiper Airborne Observatory. So this is using a telescope that is flying in an airplane. Caught that emission at 625 gigahertz. Cool. So they have found hydrochloric acid in space. Huh. There's aluminum chloride, potassium chloride, aluminum fluoride. Huh. So these are only the two atom molecules, right? O2, of course. Aluminum monoxide. Nitrogen, molecular nitrogen. So then here's the three atom molecules. So there's our famous H2O, right? That was first detected in 1969. Very cool. Hydrogen cyanide, 1971. Let's see if any of these look interesting, I'll stop. But yeah, I mean, they're all pretty interesting, right? Tricarbon. I don't know if I've ever heard of that. C3 in 1988. So this KPNO 4-meter telescope, that is the Kitt Peak National Observatory 4-meter telescope.
Hey, chat.
Check the chat.
Yeah, you're way behind.
Am I way behind? Let's see. Oh yeah. Wow, I am way behind. That's all right. That's all right. You are more than welcome to have as many conversations as you possibly want.
And,
Hey there, Daniel. Nice to see you in the chat.
And Ray, is yours a SDR play or like an RTL connected to like an up converter or something?
He will let you know. Anyway, so this is a telescope, a ground-based telescope, not a radio telescope. So they were definitely looking in the infrared at that one, right? So they were looking at vibrations, not rotations. Nitrous oxide, 1994. Emits at a bunch of different frequencies, but sort of an interesting pattern there, right? 25 gigahertz between each one. Some kind of rotational mode. There's all kinds of rotational modes and vibrational modes. So lots of different emissions could come from the same molecule. Let's see. Potassium cyanide, iron cyanide. In 2011. Wow. Okay, yeah, the Arrow 12 meter, that's also on Kitt Peak. That's the Arizona Radio Observatory. They've got a 12 meter on Kitt Peak and a 10 meter up on Mount Graham, just to the north of me. So there's HO2. Interesting. 2012. Titanium dioxide. So yeah, see, this just goes on and on and on, right? 4 atoms, and they go through all of those. Here we go. Hydrogen peroxide. HOOH. Whew. In 2011. Okay. Huh. Interesting. So pretty recently. Fulminic acid, HCNO. 5 atom molecules. Lists are getting shorter. 6 atom molecules. Methanol. Wow. So they found methanol in 1970. Oh, okay. 834 megahertz. Cool. Propanol. What else do we have here? Getting some nasty molecules now. Those unpronounceable ones. 7 atom molecules. C6H. Huh. Eight atoms. Just goes on and on and on, right? 9, 10, 11, 12. There's benzene in 2001. benzene, 13 atom molecules, and then the fullerenes. Then they've got these tentative detections, right? Where it's like, well, maybe, you know, I mean, you've seen, I mean, I've shown you all a few spectra, and, you know, they're messy. They're hard.
I want to stop Cosby right there because Rayo asked the question, and Autona says nitrous oxide, we can all have a good laugh. Thank you for mentioning about your SDRs, Ray. I have an RTL SDR dongle and a RSP1 SDR play. And Jill's there's a reason why that Jill's did not have his shows on Friday or his VHF UHF show on Saturday. It's because his phone got stolen, and he just got it back.
Yeah, that's crazy. That's crazy. And as I was saying, I think in the pre-show that yeah, I'd like to know a little bit more, right? Because it's like, you know, did somebody like swipe it from him, or did he, you know, accidentally, obviously, leave it somewhere, and when he came back, it was gone. So either way, that really sucks. So here's some tentative detections, because as I was saying, you know, these spectra are hard, right? I mean, they're complicated, lots of wiggly lines. It's like, yeah, who knows? But urea, wow. And they've got some disputed detections. So they think that maybe these are, but somebody else is saying, no, don't think so. Yeah, so then they so 32% of the molecules that we've detected in our galaxy have also been detected in other galaxies. So that's pretty good, and we're going to look at a list of those. So yeah, there are some that are detected in interstellar ices, which is pretty interesting, and also seen in protoplanetary disks. So these are, at least according to the story, right? These are disks of material, usually kind of small. Either rocky or dusty or icy, and they're in some phase of forming a planetary system. Now, whether this is true or not, I don't know. But that's what we're thinking now. So you know, I don't know. Let's see. Okay, so
Lost
here's
stolen phones with two-factor authentication is a pita bread if you don't have backup codes recorded somewhere.
is a PITA. I don't know what a PITA is.
It's panda butt.
Oh, okay. I gotcha. All right. You know, I'm just old and behind the times when it comes to these little phrases. All right. Well, cool. So here is the molecules that have been found in external galaxies. Right. So, you know, quite a few 2-atom molecules, including argon again. That's kind of nice. So I'm glad that they've found H2O. That always makes me smile. Kind of cool. Yeah. Nothing too exciting there. There's some chlorine. Oxygen. That's always nice. 4 atom molecules found in galaxies, in other galaxies.
And this is like actually found in an asteroid, right?
No, these molecules have been found in external galaxies.
Oh.
So yeah, we took the spectra of these galaxies using radio telescopes, and think that we have detected all of this stuff, all this. So 5 atoms, 6 atoms, 7, 8, 9, 12. So that's what they've seen in other galaxies, right? They've seen all of these also in our galaxy. Let's see, what is this list? The relatively low number. Okay, yeah, we're not going to get into that. So then they talk a little bit about any molecules that might have been seen in exoplanets, and they're very, very wise, right? They're sort of like, well,
They want
maybe.
that telescope up now.
Oh, JWST, yeah. With JWST, they'll be able to get a pretty good view of the atmospheres of these planets, and yeah, I mean, I think that is pretty cool, but that's moving more into chemistry and biology than it is into astronomy. So, I mean, it's extremely cool, extremely exciting, but you know, as with a lot of things, I'm not really surprised or shocked or anything. We're going to find some really, really cool stuff. So I thought that this plot was kind of interesting. Let me zoom in on that a little bit. This is the cumulative number of known molecules, right, versus year, right? So with the advent of radio astronomy, right, here we go, right? And look how linear that's been, right? Ever since. That is a really, I mean, it's a wiggly line, of course, but it's pretty straight. Pretty straight, and they've actually measured this, and this slope here, right, is 3.7 detections per year. And I mean, what we want to do, right, is we want to extrapolate outward, right? And what we like to do is, at least at first, is sort of do a linear extrapolation, right? So fit a line to this that has this slope, right? And then extend this out in time and see, in 100 years, how many molecules might we have found, and see if that sort of jives with, realistic expectations. I don't know. Is this going to flatten out at some point? I don't know. There's as I said, there are billions of molecules, so different kinds of molecules. So, are we going to run out? I think we will be limited by our technology. What this is saying, what this is telling me, right, is that the technology is keeping up with, well, it's keeping a good pace, right? We're not being technology limited here. But are we eventually going to be? I don't know. Don't know.
Hey, well, right now, the life in other galaxies probably have found about the same about us, as far as what the Milky Way is made of.
Yeah, I mean, we can look around, right? in our galaxy or in the universe, and it seems like everything is pretty much the same. Pretty much the same. I mean, you know, there's a lot going on, and you know, there's an interesting distribution and all that, but overall, you know, it looks like the, you know, so-called physical laws, those seem to be behaving, you know, the same way everywhere. And when we look out, we see the same kinds of things, right? We see hydrogen and carbon and oxygen and nitrogen and silicon and, you know, all these things, right? So yeah, I'm just not surprised at all. Not surprised at all. But yeah, I think bottom line here is that it doesn't look like our technology is limiting us in terms of detections. I just think that that's about as good as we can do, right? Because see, making a detection, as I said, relies on labs making the measurements here on the ground, right? And making those kinds of measurements can be really difficult, right? Really difficult because you have to, you know, do to these molecules what we think is happening way out there, right? We have to get them to rotate in a certain way, or we have to get them to vibrate in a certain way, and that's really hard. It's really, really hard. So the fact that they're able to do, you know, 4 of these a year, I think that's pretty good. Pretty good. All right, let's keep going here a little bit. So these are the molecules that have been detected in protoplanetary disks. So these are the star-forming, so-called star-forming disks. And when they look there, this is what they see. I don't know what HD is. Is D deuterium? It must be. Must be. Let's see. There's more H2O. Good. Good, good, good. Any HCl? Oh, I don't see any HCl. Was there any HCl up here? HCl. Oh, I don't see any HCl there either. Okay. So there's all the molecules that have been detected in protoplanetary disks. Methane, cool. NH3, right? Isn't that methane? Or is it CH4? Ooh, I don't remember. NH3 is ammonia. CH4 is methane. Yeah. Now, correct me if I'm wrong, but I think I've got that right. NH3 is ammonia. CH4 is methane. Yeah, I think so. Let's see. So this is a list of molecules detected in exoplanets. Okay. Carbon, titanium, oxygen, and hydrogen. Interesting. Pretty cool. Let's see. Oh, we're already at 175. Go down to that. Whoop, here we go. Carbon, hydrogen, nitrogen, and oxygen. Yep. Figure 6 provides a visual representation of this composition. Let's look at figure 6 really quick. Oh, okay. So the periodic table of elements, color-coded. Cool. So these are all the atoms that we've seen in space so far. Not a lot of them, just sort of the lighter elements. That's kind of interesting that it's, you know, the lighter elements. Probably partially based on the fact that there's just a lot of these lighter elements, a lot more maybe than the heavier elements. Makes sense. Haven't seen beryllium though, or barium, or lithium, or helium. We haven't seen helium in interstellar space. Interesting. Or neon. Huh. Seen iron, magnesium, sodium, potassium, chlorine, fluorine.
So in other words, we may not survive in these other planets and stuff, right?
Well, one of the things that this is telling us is that, if these are the most abundant elements in the universe, then, well, heck, these are more or less the elements for living things, for sure. At least what we consider to be alive. There's a few things that aren't there yet, right? Like the plants would like some copper. So, yeah, pretty neat though. Let's see. Yeah, I didn't really get a chance to go through a lot of this paper because it's so huge. It's a humongous paper. It's incredible the amount of work that goes into this kind of stuff. I'm not quite sure what a violin plot is. It's molecular mass. Huh, I am not quite sure what those mean. Generalized sound source, or generalized source type. Huh, okay. Don't know. Interesting shapes. But I'm not quite sure what those mean. Chemistry. This looks like a chemistry thing to me. Okay, so percentage of first detections in each generalized source type that were made at centimeter, millimeter, submillimeter, infrared, visible, and ultraviolet wavelengths. SFR. Yeah, I don't know what any of these are. But first detections. First detections. Oh yeah, and then there's this huge appendix. So let's see, 204 molecules, 11 are tentative, 2 are disputed. So mostly radio observations. 1968 started a big thing. There's 1968 again. It was a great year. I'm telling you. So yeah, pretty amazing. Pretty amazing. Let's see what this. I skimmed through this appendix, and yeah, it just flew way over my head. Sources of molecular complexity and their impact on detectability. Ooh, yeah, it's just going to be too much. Too much. There's probably a lot of interesting information here, but yeah, I'm not even going to try. Not even going to try. It's kind of interesting to look at spectra, though. Radio spectra. There's some radio spectra. Or yeah, see they changed the spectra to velocity, which is strange that they do that. I'm not quite sure what they're doing. Let's see. Is there anything else interesting? Oh, wow. We're way over time anyway, so we can probably start thinking about getting out of here. Okay, so they...
I think it's getting close around the time to blow this joint.
Blow this...
Rael's about to blow it as well.
Blow this joint. Look at all these references. Holy moly. That's a lot of references. It's amazing the amount of work.
Well, and speaking about blowing this job, who's down for some Hearts of Space?
Oh yeah, we're going to do Hearts of Space on Bobby's Rabbit right after this this live stream. So if you're interested, and go ahead and post the link if you want there, Bobby. We're going to be listening in on this week's Music from the Hearts of Space. And as I recall, it sounded interesting. So, yeah, I didn't record it again. So Bobby's been nice enough to at least offer to play it. So you know, at least I can hear it. So everybody's welcome, of course. If you're into space music and just sort of, you know, chilling out, it's a great place. All right, everybody, I'm going to check chat one more time, see if there's anything else here. More sanity? No, we don't need any more of that sanity. We need the opposite of sanity. Well, okay, all right. You know, I don't. You know, Uncle Bill, what is more insane? And you know, I've still sort of reserved judgment on all the flat Earth stuff, but I don't know. It's a little bit insane to argue with a flat earther, isn't it? I don't know. All right, you guys. Well, as I said, I'm going to get out of here. So take care. I'm just going to go one more spin around this planet. And one of the things that I want to do, I'm going to try to do it tomorrow, is I'm going to go through the calculation again to determine sort of how we're moving, right? How fast we're moving and how you and I are both moving right now. Want to run through that a little bit, do the calculation again, and see what we come up with, because it's really interesting. It's an interesting perspective, right? All right, I'm going to get out of here. I will see you in a little less than 23 hours. All right, take care. Bye.